my headset was off that whole entire time. I was explaining, I feel like I've plateaued in how much better I can get on a single day with doing the typing practice with Colmac. Um, so I think I'm going to pause on that just for the rest of the day. Tomorrow we'll keep at it, but like I feel like at a certain point it's about like repetition, right? Over long periods of time. I don't think that any more repetition today is going to help me out much. So what I'm going to be doing instead is I want to understand machine learning better, and that's something I'm interested in. So I think I'm going to do some machine learning stuff and figure out what's going on there. It's something I should know more about. And it's interesting stuff, anyways. Uh, so yeah, uh, uh, learning, machine learning, AN. Yeah, there we go. This guy. Where are the lecture notes? There we go. This is 2023, so this is actually pretty recent. Okay. Yeah, yeah. So we got the. So I got through this part, basically, if I recall correctly. Got through the matrices. We got through the log likelihood stuff, which I actually already kind of knew a little bit about. It's something came up in my undergrad about it. Then I saw this weighting stuff here, and I guess now we go on to the logistics stuff over here. Um, then after that, we'll like jump on to all the other shit that's been going on. Machine learning. Wow. Wow. Guys, how are we going to classify our data? Oh my god, guys. So I do want to like, I don't know, I do find a lot of this ML stuff very interesting. But foundation models, are they winner take all? I don't know. I don't think they are actually, just because their personalities of the models are so different. Come on. Whew. I guess that bite is just bacon. Pork. Okay. Yeah. Yeah. Good. Spam. Come on. Hot. So as it goes to so as x goes to infinity here, um, the e term goes to 0, which means it's 1 over 1, so it goes to 1. As e goes to negative infinity, e becomes much higher. I think it's closer to 0, which makes sense to me. Okay. That's very straightforward, I feel like. Okay. Sigmoid. Modi, calm down. Puppy. Hey, what are you doing? Stop it. Modi! Ah! No. You gotta stop it. You're okay. What's x0? Oh, wait. X is a vector. Oh, that's theta transpose. I see now. Okay. That's really cool, actually. So they just a vector, and okay. What are you doing? Stop it, dude. Modi! No. Dogs, I swear. Modi. Modi! Hey! Stop it, dude. Stop it, dude. Dogs. Well, that's interesting. So the derivative of g of z is g of z times 1 minus g of z. So, what's that mean? That the rate of increase is proportional to itself. Hmm. But it depends on how close it is to 1. That's interesting. That's cool. That's a cool little fact. P y equals 1. The probability of y is equal to 1 is equal to h0 of x. Probability y is equal to 0 is 1 minus it. Okay. 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 I guess that kind of makes sense. Deep learning. Learn deeply. Okay. You don't know shit until you do it, right? But we're on Kaggle, I guess. Hold up. Hold up. The probability y given x is equal to how did I come up with this one right here? It says no. It doesn't say why exactly though. Wait, hold up, hold up. I mean, this is one way you could model it. Is it the only way? I don't know. So if it's 1, then it's the first one. If it's 0, then it's the second one. If it's 0, then it's 1 minus it. Well, that's interesting. Okay. Okay. So the likelihood, yeah, so we do log likelihood stuff. It's P, the likelihood of theta where y has a series of variables, the likeliness of theta given x, the likelihood function or whatever it's fucking called, is equal to the multiplication of pyi, p, the probability of the particular example, training example, whatever the fucking name for it is, the point given x, given the training data. What's the fucking name for that? I know, God, I know this is stupid, but there's a name for it. And I need to know some of this stuff in order to, as silly as it is, I do need to know. Okay, so the thetas are the parameters. Okay, that makes sense. So what is x then in our case? What do they call x? Feature. Is that right? It's a feature or something, right? Am I calling that right? Okay. Hmm. Okay. Can we minimize the log of the likelihood? And we get the sum. Yeah, a log of h of. Ooh, that's interesting. Okay, that's gonna be pretty straightforward. Oh, fuck off. Okay. So, why does that come down again? I forget. In the log. I know this doesn't matter that much. I know it doesn't matter. Hmm. So is there a formula or no? I guess not. So, with respect to a particular theta j. Okay, so this is where I should write stuff down. So, log likelihood of theta is equal to sum I equals 1 to n yi times log h of xi plus 1 minus yi times log of 1 minus h theta. Let's put that there. Shouldn't it be h theta, right? Yeah, it should. Guess that's a typo. I don't know, maybe there's some reason for it that I don't know about. Plus 1 minus that. So then we got to do dd theta, and it's theta j. So is there not a sum there? So for a particular j, oh, ji, yeah. Okay, so theta is equal to, with respect to theta, so the y pops out. Wait, hold up. So why isn't g, sorry, what? Why is it phrased this way? So we have a dd theta j with L of theta, theta the vector itself. Here, I guess, where is this coming from? I guess part of it does make sense for you to like be able to like get outside the sum, but I don't see exactly how it's getting to that point. Oh, it's just one training example. Okay. So it's just one training example for a particular theta j. Um, the first thing we get is we get y, and the derivative of log of h of x is, with respect to theta, this partially makes sense, but not really. Just multiply that on the... Oh, I see. Yeah. I see, I see, I see. Okay. That's just chain rule shit. Okay. I get 1 minus y. Okay, so it's just expanding it out. dd theta j of g is theta tx is equal to x theta t. This is the formula we noticed before, wasn't it? The property we noticed before. So we get g theta t of x times 1 minus it. Was it times the derivative itself? I don't... Am I... misremember? Oh god, chain rule. Chain rule. Fucking duh. Chain rule, it pulls out. Yeah. Yeah. So that's interesting. Okay. Huh. Yeah, I see. Hold up. Hold up. Hold up. So we get y times 1 minus that. Yeah. Then we get that. Some j to t. Then we get there. We get dd theta j with theta t times x. So that's just theta j, isn't it? No, it's xj? Yeah, it's xj, sorry. Then you get y. Yeah, you simplify to get more. You get 1 minus. How does that cancel out? So, how does that cancel out there? So you still have the y. So where does the theta come? Oh, I see. So you get minus that there. Minus, minus, plus, plus. Okay, so it cancels out. So yg theta tx. Yeah, plus yg theta tx. Plus yg theta tx would happen to be h at 0x. That's cool. That's cool. That's really interesting. It's actually really interesting. Um, yeah, so theta j. Okay. So theta j is equal to theta j plus alpha plus the learning rate times yi minus theta c xji. Yeah, so each individual. Yeah, so you do this for each individual theta, don't you? Wait, do you do this for all thetas at the same time? So I guess you could. Yeah, you use the theta prime for, I mean, like, you could do it either way. I mean, like, there's an aggressive way, and then there's like, here's the full previous theta, and then here's the new, what's the name? Didn't they have two different names for that again? One of them was called, yeah, stochastic versus incremental. No, just incremental. So for each example, yeah. Wait, sorry, let me double check this. So we have this one right here, then we have this one right here. Interesting pattern. So you get theta j plus alpha summit for all records. This one you don't sum for all records, you just do it every single time. So you do this for all records. Then you update it. For this one, you just continually update it with, yeah. So there's batch versus incremental. Okay. Yeah. What does LMS stand for again? Least square something, right? Okay, least means square octuple. Okay. Yeah. Hmm. That's interesting. Okay. GLM models. Good dog. Good dog. The logistic function. Maps from R cross 0, 1 to the probability? So logistic laws takes in a good boy. Good boy. Good boy. Good boy. Okay. Who's a good boy? Who's a good boy? Hey! That's not what a good dog does. So we define the logistic of T and Y. Why are we defining it that way? What does this do? So the same loss function. Y, so that's equal to the, wait, hold up, hold up. So we have L theta here. Ty to R. Wait, hold up, hold up, hold up, hold up. So 2.1 is equal to 2.3, where we plug in. We can verify that by plugging in h of x. What's h of x again? I forget the fucking name for it. The fucking. What's the name of that function? There's a specific name for it. Hypothesis. So it's the hypothesis function. Okay. This is interesting stuff. Need them GPUs, baby. Okay. Oh, oh, mama. Oh, mama. Okay. So what does that mean? So the logistic function doesn't take an well, it does take an y, doesn't it? So, oh wait, no, hold up, hold up. Sorry. So theta times x. One plus one minus. No. What is log of h of x? Oh, I see. So what's the log of that again? Fuck, why am I forgetting my log? So it's technically that to the negative first, and if that comes out, that'll be the log of that. The log of 1 is 0, right? If I'm recalling correctly. I think log of 1 is 0. If I'm recalling this correctly. Natural log of 0. Why is the natural log of 0? Of 1, 0. Because the log is the inverse function of e to the x, and e to the 0 is 1. So e to the 0 being 1 means that the output for it, if the output is 0, then the input's 1. Okay. 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 Money. Money, money, money. Okay, so yeah, log of 1 is 0. So wait. No. Yeah, because log doesn't distribute. Okay. Um, yeah. Okay, so log doesn't distribute. Yeah, so that doesn't work out. So we just log of this function. So log of yeah. Yeah. Log of 1 plus what? What? No, no, no. Hold up. So log of 1. So we get some cancellations here, don't we? I can feel it in my bones. So the log of that is a negative. So then it's negative y log of that. Okay. Is it? Get 1 plus, and it's a 1 plus. So where does the 1 minus? I should probably just write this down instead of thinking it out in my head. But I kind of want to think it out in my head. So that doesn't make sense to me. If you have 1 minus 1 over blah, and you take the log of it, I don't think that distributes. What am I missing here? Wait, no. What am I missing here? Log of 1 minus something. The log of 2 things multiplied together. What am I missing here? So the thing that's stumping me up. What am I missing here? Because I'm missing something. Because the log of two values that's multiplied together is the sum of the logs, right? Maybe I'm just messing around with log property. No. We're not pulling together logs, right? Because these are two different things. So what the So how do we get from here to here then? Oh, it's negative. Jesus Christ. So, okay, that's all part of it. So it's the negative L. Okay. If L theta is equal to is equal to sum n equals 1 of negative y I ln, I guess I should put log there. Whatever. And h theta xi minus 1 minus yi log 1 minus theta. X. So that makes that y minus 1. So then we get equals to the sum and yi log of to the negative first. Yeah, yeah. Wait. That's a sum. Okay. Hold up, hold up, hold up, hold up, hold up, hold up. Theta. Wait a second. Wait a second. Oh, X. Oh, wait. So, I feel like this is really fundamental, so I need to understand it. Even though it's not probably that important in the grand scheme of things to understand the exact math behind it. I feel like I should understand this. So, this is the hypothesis given a theta of a particular x. Is this x a vector? This x is a vector. This is a vector. So then it does make sense. Okay. Okay, so it's just a vector, but I was just misreading it. Okay. Plus, actually minus here, isn't it? Minus 1 minus yi times log of 1 minus, this is where I get weirded out. Oh, I gotta put a negative 1 there. Don't forget that, Kyle. One plus e to the negative theta t xi. It's the negative first. So let's simplify that down a little bit here. Sum I equals 1 to n of y I. Oh, it's like given a particular y. Oh, that's interesting. Okay. One. I should probably attempt to write well here. E negative theta t xi. That makes sense. But then this thing doesn't. Because you can't simplify that thing, right? What am I missing here? Maybe 1 minus 1 over something simplifies? Let's do 1 minus 1 over e to the negative theta t. is gonna maybe okay. Hold up, hold up. So we get 1 plus. Hold up, hold up, hold up. Wait, wait, wait. Oh, is this it? Is this it? We'll see. I gotta figure it out myself, though. Yeah, I see. So 1 minus theta t x 1 plus e to the negative theta minus 1 minus over dot dot. So that, does that cancel out? So these two right here, you get 1, these two. No, it fucking would cancel out. Huh. Wait, am I oversimplifying this? Wait, I am oversimplifying that, overcomplicating it, I should say. So we get 1 plus e to the negative theta tx over 1 plus e to the negative theta tx minus 1 over 1 plus e to the negative theta tx. So then we get fucking A. Okay. We get e to the negative theta tx over 1 plus e to the negative theta tx. Boom. Is that right? Is that right? I don't know. Because we get the plus in there for some reason. Wait, hold up. No. How do, wait, wait, wait. That doesn't make any sense because then you get a log of that. There's no theta being pulled out of there. Okay, I'm just gonna ask Jeopardy about it. I'm sorry. I'm very confused, and I could be staring at this for hours. No, that's not what I wanted. Okay, let's ask Jeopardy. Gotta think for me. There's got to be something I'm missing here. Jeopardy's getting smarter over time, ain't it? It's really interesting how the thinking system works for it. Produce quote unquote better answers. It's like I feel like it really tells us something about human reasoning. I don't know what though. 40, 80. Holy shit. Jesus Christ. It doesn't make any sense. Hey, god damn it. You fucking kidding me? Jesus Christ. Wait. But X is hold up. Wait. Sigma. No. 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 But X is mapping from Rn to 0 to 1, right? It's Rn, right? H maps from, or sorry, the hypothesis maps from. So if we are given a okay, it's driving it weird, but it can still work, I think. Yeah. Okay. 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 Okay, so I understand the trick it's doing. They're doing. Um, and it flips. Right, that's what it was. Sigma t is equal to negative sigma t, right? Or 1 minus sigma t is equal to, yeah, sigma negative t, so 1 minus sigma. Is it 1 plus or 1 minus? It's 1 plus, okay. 1 plus, we get a e to the theta t, t x I. Okay. To the negative first. Yeah. So then we can pull out the negative first here. And that becomes a plus. Yeah. Okay. Okay. And we say theta t transpose. I'm saying theta t, but I should be transpose. So it's theta transpose x. Is equal to t? What? Where's this sum get out of here? So the logistic function takes in a real number and an output. The logistic loss takes in a real number and an output. So where does the sum come from? That does not make sense. Because y here is 0 to 1. The logistic loss takes in a real number and y. Why is it? Wait a second. Wait a second. So y is not? Oh, so that's not over the set then. It's over the elements. Wait. What the fuck? Wait, what the fuck? Wait, hold the fuck. Hold the fuck up. Hold the fuck up. I'm sorry. But y is a vector. Wait, what? But y is a vector. P is a vector. P takes y as a vector, and x is a vector too. Right? Unless the xi's are vectors. The xi's and vectors, but y. Oh, so y is a 0 or a 1 here. But the xi's are vectors. I hate that. That's such terrible notation. Okay. So yi. Okay. Okay. Christ. Okay. Okay. I see. Why is it? So L of theta. But that's a y. Wait, what? So the logic. If y is a. Y is a. Y goes from 0 to 1, though. What? So how are these related? How is this y related to this over here? I'm so fucking. What am I missing here? Where's the sum? Where does the sum come into play? Oh, wait. Is that a 0? That's not between 0 and 1. That's just the set of 0 and 1? Oh. But is into sum? Well, I guess I pressed enter anyways. So I guess it's saying that it's a logistic loss per. Okay, I guess that's per example. And then you sum these up. So the sum of all of these. Yeah. Okay, so this is probably something that makes sense in the class. They probably make it pretty explicit. But it's not exactly clear here. Which is fine, I guess. So you add this value up, right? So you add the logistic loss of the logit. Oh, that's interesting. Yeah. Okay. Okay. So that's just bad notation, I guess. Huh. Hmm. Yeah, I'll come back to this in a bit. I need to like write this for my own way of understanding it.